Okay, let's see question 3 of this assignment. For what values of r is 2r squared minus 3r greater than -7? So here r belongs to real number set. Okay, again, first of all, we need to convert it to more general form, right? We can move everything to the left. Okay, this is equivalent to 2r squared minus 3r plus 7 greater than 0, right? And apparently the left side is a quadratic function. So we need to consider the function on the left. Okay, then first of all, leading coefficient is greater than 0, then the function on the left opens up, right? Then let's find its zeros. Sorry. To find its zeros, we need to let 2r squared minus 3r minus plus 7 equals 0, right? And we can use either cross multiplication or the generic way, which is a quadratic formula, right? And I think it's not very easy to factor the left side. So this time let's use the quadratic formula. So first of all, let's calculate the determinant delta. Delta is defined as b squared minus 4 by a by c, which is 7. So this will give us 9 minus 56, right? And apparently this is less than 0, right? So that means no real solution for the asterisk. If there are no real solution, that means no zeros. Okay, so that means if a quadratic function opening up and there are no zeros, that means the relative position between the curve of this quadratic function and the horizontal axis should look like this, right? Can you follow me?
Yeah.
Okay, so this is y equals 2r squared minus 3r plus 7. This is a curve of this function, and this is a horizontal axis. And as we have calculated, there is no zeros. So there is no intersection between this curve and the horizontal axis. Okay, then we need to find any interval that makes this function greater than 0, right? And from the sketch, you can see that the whole real number set can make this inequality fulfilled, right? Therefore, the solution of 2r squared minus 3r plus 7 greater than 0 is the whole real number set, right? You understand?
Yeah.
Okay, and sometimes if you want to express it in the interval form, you can also write it as how to express the whole real number set. You can write it as negative infinity to positive infinity. Okay, this is equivalent to the real whole real number set. You can choose either way to express your solution. Okay. All right, have a look at this question.
Okay.
All right, then let's see question 4. Graph the inequality y less than negative x squared plus 4 on the Cartesian coordinate plane. Okay, so in order to graph a inequality, usually we'll consider the corresponding function first, right? Okay, so first of all, let's consider the function y equals, let's change the inequality symbol to equality symbol. Y equals negative x squared plus 4. And apparently this is a quadratic function, right? First of all, we need to sketch its graph. In order to sketch its graph, we need to convert to the vertex form. And fortunately, this is already in a vertex form, right? So this is array. A is -1, and h is 0, right? And this is our k. K is 4. And apparently, of course, you don't have to write it here, right? This is only help you to understand. Therefore, we can say the vertex of this function is 0, 4. And note here, leading coefficient is negative, then is this function opens down, right? Okay, next, to make it more accurate, usually we'll find is Y-intercept and X-intercept, right? We can let X be 0. If X is 0, we know that Y is 4. Next, we can let Y be 0. If Y is 0, that means negative x squared plus 4 is 0. Then we can solve that x squared is 4, right? This will give us x is either positive 2 or x is negative 2, right? Okay, now we have gathered all the information. First, vertex is 0, 4. Opens down. This is a y-intercept and x-intercept. Then we can sketch the graph of this function. Okay, this is y-axis, x-axis. First of all, find the vertex 0, 4. 0, 4 is, let's suppose this here. And we know that it opens down, right? So it will have a shape like this. And the y-axis is a line of symmetry, right? And there are two intersections between this curve and the horizontal axis. One of them is -2, 0. The other one is 2, 0, right? Okay, so this is a sketch of this quadratic function. But note here, actually, we want to graph the inequality, right? Inequality says y is less than. So that means this inequality is actually the region that is under the curve, right? Because it says y is less than. If y equals right side, that's on the curve. Now this time it says y less than the curve. That means all the regions that under the curve satisfies this expression. So that means, okay, first of all, this is strictly less than. So we need to use dotted line to indicate that the boundary cannot be achieved, right? It does not include the boundary. And second, we need to shade any region that is under the curve, right? Okay, so basically this is a region that corresponds to y is less than -x squared plus 4. Okay, please have a look at this question and let me know if you have any questions.
Okay.
Okay, let's see question 5. In question 5, it tells you that k is some real constant. In other words, it's a real number and it's a constant. For what value of k, the inequality x squared minus 6x plus k greater than 17 has a solution, x belongs to the whole real number set. Okay, so what does this mean? This means, in other words, any arbitrary x that belongs to the real number can make this inequality satisfied, right? Okay, so how can this be achieved? If you consider this inequality, the left side is actually a quadratic function, right? And leading coefficient is greater than 0. So actually the left side is a quadratic function that opens up, right? If somewhat this whole function is above the horizontal axis, then apparently the solution must be the whole real number set, right? Okay, so let's have a look at how can we achieve this. Okay, first of all, we need to transform this inequality to the general form, right? We can move everything to the left or right. Okay, suppose we move everything to the left, then asterisk is equivalent to x squared minus 6x plus k minus 17 greater than 0, right? Then apparently the left side now is a quadratic function. So let's consider the function on the left side. Which is y equals x squared minus 6x plus k minus 17, right? So if this function, apparently the leading coefficient is greater than 0, right? So that means this function is opening up, right? If somewhat this function is above the horizontal axis, that means no matter x is, this function is always greater than 0. That means the solution of this inequality here is a whole real number set, right? Can you follow me?
Yeah.
Okay, so how do we achieve this? How do we achieve a sketch like this? That means there is no x-intercept, right? Or there is no 0. Okay, let's say if there is no zeros, then the solution to original expression is x belongs to the whole real number set, right? Okay, following this logic, let's denote this expression with 2 asterisks. So this means this statement here means no zeros is equivalent to delta is greater than or equal to or less than 0, which is correct. Okay, let me restate. Apparently, there is no zeros for this function, right? If there is no zeros, if we write it as a quadratic function here, it should has no solution, right? You follow me?
Yeah.
So this function has no zeros. It is equivalent to this equation has no solution. So how do we achieve this? This is a quadratic equation. It has no real solution. How do we achieve this? We need to discuss the determinant delta, right? Remember that the values of delta decides the types of solutions we have, right? So if this function, if this equation has no real solution, what is our delta? Delta is greater than 0 or equal to 0 or less than 0. Which option is correct?
Less than 0.
Be less than 0, right? Only when it's less than 0, there is no real solution. Okay, so this is equivalent to delta here must be less than 0, which is equivalent to, then let's calculate our delta. Delta is b squared minus 4 by a. A is leading coefficient, which is 1, times constant k minus 17, right? So this needs to be less than 0. Only in this case, the solution is a whole real number set. So this is equivalent to 36 minus 4k, then plus, right? Negative 4 times negative 17 is plus. 4 by 17 is 68, right? This needs to be less than 0. So let's move 4k to the right side. That means 4k needs to be greater than 36 plus 68, which is 104, right? Can you follow me?
Yeah.
Okay, 4k is greater than 104. That means k needs to be greater than 26, right? Okay, now we can make the conclusion. When k, therefore 1k is greater than 26, characteristic has the solution. X can be any real number. Okay, please have a look at this question and let me know if you have anything to ask, okay?
Okay.
All right, if no questions, let's see the next one. What values of X satisfy the inequality? Okay, basically ask us to solve another quadratic inequality, right? Okay, let's call this asterisk. So the original inequality is equivalent to, first of all, we need to put everything to the left or right. So let's put everything to the left. This is equivalent to the original one, right? So as long as we can solve this inequality, we can solve the original one. Okay, then in order to solve it, let's consider the quadratic equation on the left. So consider the function on the left, which is y equals x squared minus x minus 1, right? Then we need to find, basically we need to find an interval that can make this function less than 0, right? So apparently it's better to sketch the graph of this function, and then we can find corresponding intervals. So apparently this function opens up, right? Okay, first of all, it opens up, we have already know. Then let's find its zeros. So in order to find zeros, we need to let x squared minus x minus 1 be 0, right? Then find any values of x that can satisfy this equation. Okay, and apparently this is not easy to factor, right? So this time we'll use the more generic way to solve it, which is a quadratic formula. So first of all, let's calculate the delta. Delta is b squared minus 4 by a is 1 by c is -1. So this is 1 plus 4, right? Plus 4, which is 5, right? Then we know that x is 2a, which is 2. Negative b is 1. Then positive or negative square root of 5, right? These are the two zeros of this function. So basically, this function will have a curve like this. Opens up, and there are two zeros. So basically, it will have a shape like this. This is a horizontal axis. And one of them is 1 minus square root of 5 over 2. The other one is here, which is 1 plus square root of 5 over 2, right? These are the two zeros. And our job is to find any interval that can make this function less than 0, right? Note here, this is strictly less than 0. So first of all, these 2 points cannot satisfy the inequality because at these 2 points, the expression is exactly 0. And next, we need to find any interval that can make this function less than 0. Apparently, this is the interval, right? This interval can make this function less than 0. Therefore, we can make the conclusion. Therefore, the solution is x is greater than 1 minus negative square root of 5 over 2 and less than 1 plus square root of 5 over 2, right? And also note, you can also say from 1 minus square root of 5 over 2 to 1 plus square root of 5 over 2. This is just another expression of this interval. Okay, have a look at this question and let me know if you want to ask anything.
Okay.
All right, then let's have a look at the next one. Solve this inequality. Again, this is a quadratic inequality, right? So first of all, you can move everything to the left or right. Original expression is equivalent. So because the leading coefficient is already 1, which is greater than 0, so it's better to move everything to the left in order to simplify this question, right? Okay, so now let's consider this inequality. In order to solve it, we need to consider the function on the left, right? So let's consider the function y equals x squared minus 4x minus 21, right? Apparently, the leading coefficient is greater than 0, so it opens up, right? Has a shape like this. And then we need to find its zeros. Okay, in order to find its zeros, we let x squared minus 4x minus 21 be 0 and find corresponding x's, right? Okay, so by observation, 21 is actually can be factored to 3 by 7, right? And the difference between 3 and 7 is 4. So it's possible to use cross multiplication. So minus 21 can be factored to negative 3 by 7 or 7 by negative or 3 by negative 7, right? Because we have negative 4x in the middle, so probably I'll put a negative symbol here. And by examining the cross multiplication, we'll get 3x minus 7x, which is negative 4x, which is exactly this term in the middle. So it's possible to factor this expression to x plus 3 times x minus 7 equals 0, right? Therefore, the zeros are x is either negative 3 or x is 7, right? Okay, now we have. Okay, so basically we have a quadratic function that opening up, and there are two zeros, which are negative 3 and 7, right? Okay, then we need to find any interval that can make this function less than or equal to 0, right? So first of all, these two intersections can be included because at both points they can make the function equal 0, right? And next we find any intervals that make this function less than 0, and apparently this interval can make this function less than 0, right? Okay, now we can make the conclusion. The solution to the original expression is x can be greater than or equal to negative 3 and less than or equal to 7, right? Only in this interval, this function is less than or equal to 0. Understand?
Yeah.
Okay, and also you can also say, if you use the expression of intervals, you can also say x belongs to an interval from negative 3 to 7, right? Note here, if the boundaries are inclusive, we use this symbol, right? And you can choose either way to express your final solution, okay? Please have a look at this question and let me know if you have anything to ask.
I'm good.
Okay, next one is to graph the inequality. Y is greater than t squared minus 3t minus 21. Okay, as I said, to graph a inequality first, usually we'll consider the corresponding function first, right? So first of all, consider the function. You can only make this inequality symbol to be an equality symbol to make it a function, right? Consider the function y equals t squared minus 3t minus 28, right? So apparently this is a quadratic function, right? And leading coefficient is greater than 0, so it opens up. Next, we, in order to better sketch it, we need to find its vertex, right? So note here, we have already had t squared, so negative 3t can be factored to 2 by t by -3/2, right? So this is the number we're looking for. So we can try using t minus 3/2 squared, right? Okay, and if you expand it, you will get t squared minus 3t plus 9/4. There is no 9/4, so we need to subtract it, right? And then copy the rest of the expression. Then which can be further simplified to t minus 3/2 squared minus 9 plus 28 by 4/4, right? Can you follow me?
Yeah.
Okay, so this is t minus 3/2 squared minus, okay, let's calculate the number here, 28 by 4, then plus 9, 121/4, right? Okay, so basically this is a vertex form, right? Now we can say the vertex is 3/2, -121/4, right? And next, in order to better sketch it, usually you will find its y-intercept and x-intercept, right? So first of all, we let x be 0. Oh, sorry, t be 0, right? If we let t be 0, then y is -28. So the y-intercept is just 0, -28. Then we can let y be 0 to find its t, right? If y is 0, that means t minus 3/2 squared minus 121/4 is 0. Therefore, t minus 3/2 squared must be 121/4. Okay, that means t minus 3/2 must be positive or negative square root of 121/4. Fortunately, 121 is a perfect number here, perfect square number here. So this is 11/2, right? Therefore, t is either positive 11/2 plus 3/2, which is 7, or t is negative 11/2 plus 3/2, which is -4, right? Okay, then let's make summary. We have vertex, direction, y-intercept, t-intercept, or horizontal intercept. Then we can sketch the graph of this function. So this function will have a graph like this. Vertical y, horizontal t, right? Okay, then the vertex is 3/2, and then a very large negative, a very small negative number. So for example, this is a vertex. 3/2, then -121/4. Then it opens up, right? So basically it will have a shape like this. In order to draw it, let's have a look at the y-coordinate, a y-intercept. Y-intercept is -28, so this is y-intercept. And the two x-intercepts are -4, 0. And the next one is 7, 0, right? Okay, so basically this function will have a sketch like this. And remember, it's not over yet. We need to find the region that corresponds to the inequality, right? When y equals the right side, it's on the curve. Now this time we want to find that all the point that the y coordinate greater than the right side, which means the region should be above this curve, right? And also know y is strictly greater than. So that means the boundary does not include, cannot be included, right? So we need to use dotted line here to indicate that the boundary is not a part of this region, but any region that is above the curve. Okay, this is y greater than t squared minus 3t minus 28. Okay, please have a look at this question and let me know if you have any questions.
Okay.
Right, so